Exercise. Determine whether or not plug holing is likely to occur from a vent located 2.5 metres from the edge of a reservoir with the following parameters. You've got your density of ambient air is 1.177 kilograms per metre cubed. Acceleration due to gravity is 9.81 metres a second squared. And you've got your ambient air temperatures 293 degrees Kelvin. Your theta value, your temperature increase is worked out at 78 degrees Kelvin. And your smoke layer depth is 1.8 metres. So it's got quite a narrow smoke depth. Your aerodynamic vent area of each vent is 3.44 metres and the ventilator has a coefficient of 0.6. Your temperature of your smoke layer is worked out at 371 degrees Kelvin and the smoke leaving each ventilator is 31 kilograms a second. Now, as the ventilator is located more than 2 metres away from the edge of the reservoir, this is the formula you should be applying. Where mcrit is the maximum amount of smoke that can enter a ventilator without plug holing occurring. Yet rho 0 is your ambient air density. You've got your gravity, 9.81 metres a second. You've got TO, which is your ambient air temperature. Your theta is your increase in temperature of smoke. Your D is your smoke layer depth. TL is the temperature of the smoke layer in metres. WV is the width of a circular ventilator with the same area as any other vent. Because you're not sure what size vent, what shape you're going to have, you have to convert it to a circular ventilator to make this formula work. So that's what WV is. Now, you've got to determine WV, and this is the formula to apply. WV equals 4 times AV per vent. Now, this is the geometric area. This is once you've taken into account the efficiency of the ventilator, divided by pi, and the whole lot square rooted. That's what you have to use, this formula. When you put all your known variables in, you should have got this. WV equals 4 times 3.44, which is the aerodynamic free area of the ventilator, divided by 0.6, the coefficient. You multiply that out, you divide it by 3.142, and you square root it. Your WV, your width of an equivalent ventilator, is 2.7 metres. When you put this into the formula here, the mcrit formula, your 2.7 metres, you'll have got an mcrit of 16.39 kilograms a second. So if more than 16.39 kilograms a second goes through each ventilator, it is likely to plug hole and entrain air and not be efficient. That's it. So in this case, the smoke leaving each ventilator, we've said in the example, was 31 kilograms a second, and the mcrit is 16.39 kilograms a second, which means in this case, it is very likely that the plug holing will occur. Yeah, plug holing will occur now, so you will get air entrained in, you need to do something about it. One method, possible method of doing, is having more smaller vents in each reservoir, but it will plug hole.